Hi grade 12s and welcome to this video. In this video, we will be working on the mathematics end of term test for 2024. So this was around March, it should be around March. And this is specifically from the Gauteng province and it's Johannesburg North District specifically. I know there is a Johannesburg Central District. That's not this exam paper. Okay, grade 12s, this exam paper is 100 marks and it is 2 hours long. Okay, we have our instructions. Make sure to round off to 2 decimal places unless stated otherwise. And also just remember that the diagrams are not necessarily drawn to scale. Remember that I am uploading these question papers, okay? So the 4 exams, 2022, 23, 24, and 25. So you can use that to practice because what you will notice in March is different topics may have been worked on in different years. So the topics that were worked on in March, for example, 2022, may be different from the topics that were worked on in 2024. Okay, so you can just use the 4 papers just so that you can get as much topics depending on whatever topics you guys are focusing on in term 1. Okay, so with that being said, let's get into this video. Question 1.1 says we need to solve for x in each of the following. Now, in this question, do you see that the right-hand side is already equal to 0 and these have been factorized for you? So all we have to do is equate each bracket to 0. So x minus 2 is equal to 0, and so if you transpose, therefore x is equal to 2, or x is equal to -9, and these are our answers. Moving on to the next question. Question 1.1.2 says we have to solve for x correct to 2 decimal places. Now, do you notice that in this question, we have one hand side of the equation that is not equal to 0, despite this being a quadratic equation. So what we can just do is transpose this, and so we have 5x squared, and this is minus 6x minus 2 is equal to 0. Now we have to correct to 2 decimal places, so this means that we're going to have irrational solutions. And since it is a quadratic equation and it is in the form of ax squared plus bx plus c is equal to 0, we can now use the quadratic formula on this. Okay, so here's the quadratic formula, and this will help us to solve for x. So we have negative, and b is -6 as we can see, so we'll say -6 plus minus the square root of b squared, -6 all squared, minus 4, and a is 5 while c is -2, so minus 2, and then all over 2a, so 2 times 5. And let's see what we get as our first solution, and our first solution is 1.47, or x is equal to, and we'll just change that to a minus, and we have -0.27 rounded down to 2 decimal places. And those are our answers. Moving on to the next question. Question 1.1.3 says we have this inequality and we have to solve for x. So it's quadratic, so you can use any method that you use to factorize these quadratic equations. But here, do you see that what we have is this 2 is in front of x squared, and it's not a common factor, okay? So we have to just factorize it like this. So I'm going to use the cross method. We'll open up 2 brackets, of course, and say this is still greater than or equal to 0. Now, let's look at 2x squared. To get 2x squared, what did we multiply together? We must have said 2x multiplied by x. And then to get 3, what did we multiply? Now, specifically, this is a -3. So we could have said 3 times 1, or you could write this as 1 times 3. We'll see which one would help. If we said 3 times 1, we would have said, with the cross method, when we multiply them, we should get the sum of these values as the middle term. So 2x times 1 is 2x, and x times 3 is 3x. Now, I know when you add them together, they could give you a 5x, but you need to remember that one of these numbers are negative since we have a -3, okay? 3 times 1 needs to be negative. Okay, so that means one of it should be negative. It could be the 2 or it could be the 3. Now, looking at this, you can see that if one of them are negative, they will never give you -5x. Okay, so now instead of trying it as 3 and 1, we're going to just try that as 1 and 3. And if you multiply, you see that cross multiply, we get 6x, and then x times 1, we get x. Now, this can definitely give us a 5x if 1 is negative, but we need to ensure that it's a negative 5x in the middle. So give the negative to the bigger factor. So we have negative 6x plus x, which gives us negative 5x, and there we go. So how did we get the 6x? We need to give the negative to whichever factor that caused us to get this negative 6x. It was because we said 2x times 3. So give the negative to the 3 and the positive to the 1. And so our factors are 2x plus 1 and x minus 3. Okay, so that's using the cross method. And now we can finally just find our critical values. So those would be those markers, those points that will help us find the solution to our inequality. So it's like equating this to 0. If you equated it to 0, you would have to transpose the 1, which makes it negative, and then divide both hand sides by 2. So one of your critical values are x is equal to negative 1 over 2. Okay, and the second one would be x is equal to 3 when you transpose. And now let's solve for this inequality. So notice that it says that this expression, okay, we need to find the values of x for which this expression is greater than or equal to 0. This is a parabola, specifically a concave up parabola, since we can see the value of a is greater than 0. So if this is a parabola and it is a concave up parabola where we have the critical values, negative 1 over 2 goes here and 3 goes here, for which values of x will this be greater than 0? We can look at where they are equal to 0. So if we say that they are equal to 0, we're referring to their y values. You notice that negative 1 over 2, okay, that's an x-intercept. So it means that at this point, its y value is 0. And so where are the values greater than 0? Well, we have positive y values or values greater than 0 all through here. So it means that we can only take parts of the graph that map to these positive y values. And if you do that, you see that all of the parts of the graph that have positive y values are parts of the graph that lie above the x-axis. Okay, so we're just going to mark that alone. We don't have to look at all of this. We don't even have to look at the y-axis. We're only going to look at the parts of the graph that lie above the x-axis. And when we line this down to the x-axis to better understand their x values, you see where these values point towards. They are, if this is negative 1 over 2, the values are pointing towards values to the left of negative 1 over 2, which are values that are less than negative 1 over 2. So our first solution is x is, I'll just put it here. Okay, our first solution is x is less than negative 1 over 2. Do you see how the direction and the inequality look the same? Or, and then over here, again, line this down to the x-axis and you see that these are values to the right of 3. So these are values that are greater than 3, moving this way. So x is greater than 3. But you also need to take into account that this is less than or equal to 0. If you substitute these actual values, you see that they will have a corresponding y value of 0. So we're saying that x is less than or equal to negative 1 over 2, or x is greater than or equal to 3. And those are our solutions. Moving on to the next question. Question 1.2 says, solve simultaneously for x and y in the following equations. Okay, so we're given two equations. Notice that one equation is linear, okay? It doesn't have any x squared or any xy, anything like that. So in this equation, we can easily make x the subject. So we will leave x on the left-hand side, and then let's transpose. So when the negative 3 goes over, it becomes positive 3. And when the 2y goes over, it becomes negative 2y. And we can call this our equation 1. And so we'll keep this as equation 2. Okay, so now we can go ahead and substitute equation 1 into equation 2. So wherever you see x in equation 2, replace it with 3 minus 2y. Okay, so we have x squared. So we'll say 3 minus 2y all squared. Minus, now we have 3xy here. So x is there, but y is still here. So why don't you just put the y in front of the x and we have minus 3y and then the x. And we'll replace that with 3 minus 2y and then plus 5 y squared is equal to 3. And this will help us to solve for y. Okay, and now to distribute. So with these, instead of writing this twice and then foiling out, we can't just do this like this. Okay, so we're going to square the first term, which gives us 9, square the last term, which gives us positive 4y squared. First term times second term is negative 6y. Then you need to multiply that by 2 because it's going to become double. So it is negative 12y. And then we distribute here as well. This is negative 9y, and that is positive 6y squared. And we have plus 5y squared is equal to 3. Okay, so now let's join our like terms together. So we've got the 6 and the 4, which give us 10, and then plus 5 is 15. So we have 15y squared. And then we have negative 12y minus 9y, which gives us negative 21y. And then constants. Okay, we still have this 3 here, which honestly I should have transposed at some point already. So I'm going to say that we're going to transpose it here. So it becomes minus 3 is equal to 0. And 9 minus 3 is positive. 6 is equal to 0. Now we have another quadratic equation. But do you notice that throughout we have a common factor? We have a common factor of 3. So we can just divide both hand sides of this equation by 3, and now we have 5y squared minus 7y plus 2 is equal to 0. And let's factorize. Okay, so again, using the cross method, we're going to say factors of 5y squared. 5y multiplied by y give us 5y squared. And then 2 is just a prime number as well, so it's just going to be 2 and 1. But it depends on how you structure it. So I usually start with it as the bigger one on top and then smaller one on the bottom, and then start checking whether this is going to work out or not. Now, in this equation, notice that only the middle is negative, meaning for you to have gotten this positive, it's either that you had 2 positive terms multiply or 2 negative terms multiply. Now, which do you think it's going to be since you have a negative in the middle? It's obviously going to be the 2 negatives multiply, because if you have 2 positives multiply, then there shouldn't be a negative. Okay, so these are going to be negative. Negative 2 and negative 1, okay, multiply give us positive 2. And let's cross multiply to see if we get the middle term. So 5y times negative 1 is negative 5y. Y times negative 2 is negative 2y. And then this indeed does give us negative 7y. So these are our factors. So 5y minus 2 multiplied by y minus 1 is equal to 0. And so therefore, let's solve for y. We have 5y and then is equal to 2. Divide both hand sides by 5. Y is equal to positive 2 over 5. Or y is equal to transpose, that is positive 1. So this is what we have as y. And now we still need to solve for x. So if you have y, just find an equation that has x as a subject. And we already had an equation like that. That is this equation. So we'll say x is equal to 3 minus 2y. So x equals 3 minus 2. And then this is y, 2 over 5. Or x is equal to, that's 5. X is equal to 3 minus 2 and then 1. So this means that we're going to have x is equal to, you can't just use the calculator. This is 4 over 5, and then this can be put over 5 by making it 15 over 5. 15 minus 4 is 11, so we have 11 over 5. Or x is equal to, and here we have 3 minus, and this just becomes 2, so which is 1. And there we go. These are our answers, okay? X is equal to 11 over 5, and y equals 2 over 5. Or x is equal to 1, and y equals 1. And that is our answer, and that is it for question 1, which is a total of 17 marks. Question 2, 2.1 says, given Sn is equal to n squared plus 2n, determine S of 100. Okay, the sum of 100 terms, the sum of the first 100 terms. So you see that the difference here is that they just substituted 100 in place of n, and that's all we're going to do. So the sum of 100 is equal to, and there's n, so we'll say 100 squared plus 2 times 100. And then we'll find our answer. And that is 10,200. Okay, and that is the sum of 100 terms, the first 100 terms. Moving on to the next question. Question 2.1.2 says, determine the first 3 terms of the original pattern. Okay, so they want us to use what we have here, the sum formula, to find the sum of the first 3 terms. Here's how we can find term values, even if we just have the sum formula. Think about it like this. Okay, so if we had the sum of three terms, right? Just think about what this is made up of. The sum of the first three terms is made up of term 1 plus term 2 plus term 3. Now, if we found the sum of the first two terms, which is just made up of term 1 plus term 2, right? And we said the sum of three terms minus the sum of two terms. So you would take this entire three terms, 1, 2, and 3, and then you subtract it by term 1 and term 2. What will be left? It would be term 3. And so this is a way to find the third term. The third term would be equal to the sum of three terms minus the sum of two terms. Okay, if you take all of that and you say sum of three terms minus the sum of two terms, you're only left with the third term. Okay, so the general formula for that would be to find a term, right? We say the sum of that amount of terms minus the sum of amount of terms that are just one less than that. Okay, so that's it. And then how do we find term 2? We find this by saying the sum of two terms minus the sum of one term. And then to find the first term, you would simply just say the sum of one term. And that's it. That will be the first term, okay? Because the sum of one term, it's the only term that was added. Okay, so let's use our formula. So our formula is this. Now just rewrite it here. And let's just write this out. So we're going to find the first term by saying term 1 is equal to the sum of one term, which is going to be 1 all squared plus 2 times 1. Okay, and then that just gives us 3. And then the second term would be the sum of two terms minus the sum of one terms. So that would just be, let's just take 2 all squared plus 2 times 2 minus the sum of one terms, which is just 3. Okay, so minus 3. And so that is going to be 4. That's 4. That's 8 minus 3, which is 5. And then the third term. So we'll take the sum of three terms minus the sum of two terms. So that is equal to, we'll just say 3 all squared plus 2 times 3. And you're subtracting by the sum of two terms. We already know the first term is 3 and the second term is 5. So that's minus 8. Okay, so those terms. And then that gives us, so that's going to be 9. We have 9 plus 6, which is 15. And so 15 minus 8 is 7. Okay, and so there we go. And that would be our terms. So our first three terms we can just conclude are 3, 5, and 7. And that is our answer. Moving on to the next question. Question 2.2 says, calculate the value of n if it is given that the sum of the series with the formula 5 minus 2k, starting where k equals 2 and ending at n, is equal to this. Okay, so we already have the sum of the series. Now you need to watch out for this part. You see that it starts where k is equal to 2. Okay, so there are two values of n that we can think about here. There is n, the number that we clearly ending at, that is different, okay, from n, the number of terms that we have. So this is n, the number that we end at, and we need to remember that this is not the same thing, okay? And then we have n, the number of terms, and this is the one in the SN formula. Now, how we calculate this is like this. You're going to take the number that you end at minus the number that you start at, and then plus 1. And that will give you the full number of terms available. So this is n minus 2 plus 1. Okay, just like if we had the sum of a series, starting at, let's say, k equals 3 and ending at 5. Now, it may look as if there are 5 terms in this pattern, but remember you're starting at k equals 3. So it means you have the terms where k equals 3, k equals 4, and k equals 5. That's a total of 3 terms. So if you had said top minus the bottom number plus 1, you would see that 3 minus 5 is 2 plus 1 is 3. And you see that that is actually 3 terms. Okay, so that is the case with that. You need to always watch out for that if you see that it didn't start where k equals 1. Okay, now look at our series, okay, and the formula. From that, you can already see that this is linear. It's an arithmetic pattern. So what we would have to do is we can actually expand this first. So you do get a mark for your expansion. So we can just say the sum of the series starting at k equals 2, ending at n, with this, okay, formula that it is equal to, and then let's just substitute. So when we substitute 2 in place of k, that's going to give us our first term. So that's 5 minus 4, which is 1. And then the next term is going to be 3 in place of k. So that becomes negative 6, and this is 5 minus 6, which is negative 1. You can choose to write this as 1 and plus negative 1. That's fine. Okay, and then plus, and then the next term. So if we replace in place of k, we put 4 now. That's going to be negative 2 times 4, which is negative 8. So 5 minus 8 equals negative 3. So plus negative 3. And this is the expansion. And then from this, we can get everything we need. So from this, we know that they already told us the sum of the series, that it is equal to, the series is equal to negative 800n over 17. So here's the thing. We can go ahead and put down our formula. We can see that this is an arithmetic pattern. You see it is 1, negative 1, negative 3. So what did you do from 1 to get to negative 1? You must have said minus 2. And then from negative 1 to get to negative 3, minus 2 again. So that constant difference is negative 2, just like we can see it over here, okay? The coefficient of k. Okay, so remember this is an arithmetic series. So in order to find the sum of terms, you can either use this formula or you can use the formula with the last term. Either ways, it's fine. But here's the thing that you're going to have to remember about the last term. Because it ends at n, it will just be a result of substituting n in here, meaning your last term would simply be 5 minus 2n. Okay, so we can just go with this because it's a simpler formula to use. And so we're saying the sum of n terms. Now we know that n here stands for the number of terms. And we know that that is n minus 2 plus 1, which simplifies to n minus 1. Okay, so we'll just say the sum of n minus 1 is equal to n minus 1 over 2. And then in place of a, we're just going to substitute our first term, which we know is 1. So that's 1 plus, and then our last term, which I should have actually just left out. So I'll just say L is equal to 5 minus 2n. So that is the last term. And now we can go ahead and start solving. So we know that the sum of these terms, they give us this, negative 800n over 17. And this is equal to, we still have n minus 1 over 2. And that gives us 6 minus 2n, and then we'll multiply in. So this is negative 800n over 17 is equal to, and when we distribute, this is what we're going to get. You see, you're multiplying by a 6. So 6 and 2, because 6 is in the numerator, it has a natural denominator of 1. So 6 and 2 have 2 in common. So we can just say 2 divided by 2 is 1, 6 divided by 2 is 3. And so you're really just saying n minus 1 times 3. So the 3 can multiply by the n and the negative 1, giving us 3n minus 3. Okay, and that's what we get there. And then we have negative 2n multiplied by the n minus 1 over 2. Okay, we're just distributing into here. So that gives us, you see that across we have 2 in common. So divided by 2, that 2 cancels, and divided by 2, it's a 1. So this is negative n multiplied by n minus 1. And so that is going to be, we can just choose to write it here already, negative n multiplied by n minus 1, and then we'll just go ahead and distribute that. Okay, so let's try to get one term here because this is already a fraction. So leave this as negative 800n over 17 is equal to, and this is 3n minus 3, and distribute, this is negative n squared, and that is positive n. Okay. And this is equal to, okay, so at this point you see that we're going to eventually have to multiply both hand sides by negative 17 to just get that off the denominator. So this is negative n squared that we have. And then these two, they make up positive 4n minus 3. Okay, and then at this point I'm just going to multiply. So we can multiply both hand sides by 17 or negative 17, that's fine. So multiply by negative 17 and it cancels out this 17. And because negative times negative is positive, this stays 800n is equal to, and you're multiplying by something with one term, meaning we're going to use brackets here. And now we're going to distribute, and I'll just leave the calculator here. So let's multiply. That is going to be positive 17n squared. And then 4 times 17, that's 68. So negative 68n. And then 3 times 17 is 51. So that becomes positive 51. And we can transpose this 800n. So this is 17n squared minus 68n minus 800. And when we transpose, you see that this is just going to be negative 868n. And then plus 51 is equal to 0. Okay, so this is what we have, and we just need to solve for n. So it probably has common factors. We know that 17 is a factor of 51. So there's probably a common factor of 17 all through. So we can just say, what is negative 868 divided by 17? No. Okay, so there's no common factor, unfortunately. Here's how we can also just solve for this, just to get the answer quickly. We can use the quadratic formula, but I'm not going to use it, like show it here, because these may have factors. Okay, so let's go ahead and substitute. We're going to say negative b, and so this is negative 868, and then plus minus the square root of b squared, which is negative 868, all squared, minus 4 times a, which is 17, times c, which is 51, and all over 2a. So 2 times 17. Okay, so we get 51, meaning these are one of the solutions. N is equal to 51 is one of the solutions that we will have. And so what that means about the factors that we should have gotten, one of the factors would have been n minus 51. So you'd say n minus 51 equals 0 and then transpose that negative 51. And so what did we have here? You can just change that to a minus to get the other solution. And it's still decimals, but just put it as a fraction. And so you see that n was equal to 1 over 17. So what does that mean about your factor? You must have said n and then take that over. It's minus 1 over 17. And then this 17 was here in front of the n. It was 17n minus 1. And that's how you were able to equate this to 0 and get it to look like that. So this is 17n minus 1. Okay, so there we go. Those are our factors. And we can just tell them here, n is equal to 1 over 17. Okay, so here we go. Now choose which one would be valid, because this is a pattern. Okay, term numbers cannot be fractions. You cannot have the half term. Okay, there's no such thing. But you can have the 51st term. So it means that we're not going to accept this answer. We're going to accept this one. So we'll say that n is therefore equal to 51. Okay, now what is this n that we were solving for? Initially, do you see that we were able to find out that the number of terms, right? That was n minus 1. That's what we put there. So n was specifically the number we end at, that over there. So since we already told ourselves n minus 1 was the number we end at, we already accounted for that, okay, that it does not start at k equals 2. And so this n that we just solved for is the number that we end at. And that's exactly what they were asking for. They were asking for that. So what is the value of n over here? It is exactly 51. And so that would mean that this is actually the sum of 50 terms, okay? Because n minus 1, 50 terms. And you can actually try that. You can go ahead and find the sum of 50 terms, making sure that a is equal to the result of substituting 2 in here. And then you could even use the formula with d so that there's no confusion. And you would find that the sum of those terms would be equal to this and then times n, if n, of course, is equal to 51. Okay, and that is our answer. Okay, and that is it for question 2. Question 3.1 says, prove that for any geometric sequence that the sum is given by Sn equals a, okay, and this is the one that says 1 minus r raised to the power of n over 1 minus r, where r is not equal to 1, if the first term is a and the constant ratio is r. Okay, so this is something that you'll find at the beginning of your textbook, okay, in sequences and series, and they show you the proof of the sum series for the geometric and the arithmetic series. Okay, so we are dealing with the geometric specifically, and we should also remember that this is the one that says 1 minus r to the power of n. Okay, let's go. So to derive a formula for this series, think about what it is. It's the sum of terms, okay, in a geometric sequence or series. So we are adding up term values. So let's think about how we could do that. How could we find the sum of an unknown amount of terms, okay? How we would find that is by adding each successive term. So we're going to say term 1 plus term 2 plus term 3, and we're going to keep going. But the thing about these, term 1, term 2, and term 3, is they actually have variables that we can call them. So the Tn formula, the formula for you to find term values, it looks like this. For a geometric sequence, it is Tn equals a multiplied by r raised to the power of n minus 1. So if you wanted to find the first term, you will notice that if you substitute 1 in place of n, you're going to get, you see in this case, it's just minus 1, which is 0, and then anything to the power of 0 is 1, and then you see how you get a, right? So the first term is a. And if you did this to the second term as well, you would see you have a multiplied by r raised to the power of 2 minus 1. 2 minus 1 is 1, and then so that's just r, okay? And so you have ar, so plus ar. And what keeps happening is, because this is a geometric sequence, we will keep multiplying the previous term by r to get the next term. So to get the third term, you'd say ar times r, and that will give you ar squared, and then ar cubed, and so on. And so the last term would be, remember that this is looking at it as if it is an unknown amount of terms that we are adding up. So the last term, we would call that ar to the power of n minus 1. Okay, really the formula of how these are going, it's ar to the power of n minus 1, because depending on the term number this exponent is always going to be 1 less than the term number. Now, for the sake of understanding this, let's find the second last term. If the last term is ar to the power of n minus 1, what would the second last term be? Well, think about how these terms are moving forward. Okay, we have ar to the power of, technically, this is ar to the power of 0, okay? And then this is ar to the power of 1 and ar to the power of 2. You see that the r's are just increasing. So they become 1 more than what they used to be. So that means if we were going backwards, the r's would be decreasing. They would become 1 less than what they used to be. So if this is ar to the power of n minus 1, then the previous one is going to be 1 less. And if you subtracted a 1 from that exponent, look at what you get. You get ar to the power of n minus 2. Okay, and then the previous one, ar to the power of n minus 3, and so on. So this is what the sum of our series looks like. Now, we're not done because we can't just add these up together. So we'll go ahead and call this our equation 1. So this is equation 1 that we have. And now, in order to derive this formula, we're going to create a second equation. And we're going to create this equation by multiplying the first equation by r. So we're taking equation 1, and we're going to say equation 1 multiplied by r. And when we do that, remember that you're going to multiply by r to the left and the right hand side. So this will now become, on the left hand side, we have rsn is equal to, now every term here is going to multiply by r, because you're saying everything here times r, so that r will distribute in. And now we have ar plus ar squared plus ar cubed plus, and this keeps going. And then the second last term now will be, you see, because you're multiplying by an r, what that r is doing is when it multiplies to this r here, its exponent of 1 just adds to that term. Okay, just like here, ar cubed. Okay, it just added by 1 in that exponent. So think about what happens when you have ar to the power of n minus 2 and you add 1. You're going to have ar to the power of n minus 1. Okay, negative 2 plus 1. And so that's what we have there, ar to the power of n minus 1. And then this last term, when you multiply by r, you have a negative 1. You're going to say plus 1. So that cancels. And now you have ar to the power of n. And this is our equation 2. Okay, so now that we have our two equations and we've multiplied by r here, now in order to solve for this, we're still trying to solve for Sn. we have Sn and Rsn. We're going to subtract our equations because do you see how these are subtracting, right? It's because some subtraction went on there. So how we're going to do this is you're going to have to think about it now. You could either say Sn minus Rsn, or you could say Rsn minus Sn. Now you have to think about which one is appropriate for the formula they've given you here. Okay, if you did this, do you see that in order to make Sn the subject, right, you would have to take it out as a common factor. So what would you be left with? You'll be left with 1 minus R. Now if you had to take Sn out as a subject here, it will be Sn multiplied by, and what's left here, it's R, and what will be left here? Negative 1, okay, because you say negative Sn divided by Sn. And do you see now, based on the formula they've given us, we are supposed to go with this one that says 1 minus R, okay? So we're going to make sure we say Sn minus Rsn. The equation of Sn is equation 1, and then this is equation 2. So we need to say equation 1 minus equation 2. Okay, so left-hand side minus left-hand side. So we're going to say Sn minus Rsn is equal to, and then right-hand side minus right-hand side. So just look at what happens with the right-hand sides. Do you see that in these, right, we have some terms that are identical, exactly the same. Here you have AR, the second term, but here the first term is also AR. So when you say equation 1 minus equation 2, you're going to say that AR minus this AR, and they will cancel, okay? Like the same thing minus the same thing, they become 0. And this is going to happen to the other terms that are exactly the same. AR to the power of 2 will also subtract with this. So AR to the power of 3 would also subtract by this AR to the power of 3, that next term. Now here, this term of AR to the power of n minus 2 would subtract with this previous term's AR to the power of n minus 2. And then this term, this is the last term in equation 1. It will subtract with the second last term in equation 2. So it's gone. Okay, so all these ones marked in blue, they are all gone because they become 0. And what are we left with? Remember, we are saying equation 1 minus equation 2. So what's left in equation 1? It's only A. So we'll say A minus, and what is left in equation 2? It's only AR to the power of n. Okay, so AR raised to the power of n. And this is what we have. And now we can focus on making Sn the subject. We know how to do that now. It's by taking it out as a common factor. So we'll have what is left, 1 minus, and then we have R. And in our second term, do you see that here we also have A common? So we take A out as a common factor. And what are we left with in the first term? 1. And in the second term, minus R raised to the power of n. And now to make Sn the subject, we will simply divide both hand sides of this equation by 1 minus R. 1 minus R. And once we divide both hand sides, this finally means that Sn is equal to A multiplied by 1 minus R raised to the power of n over 1 minus R. Remember that in this case, R should not be equal to 1. Because if R is equal to 1, you're going to have 1 minus 1, which ends up being 0, and you have a denominator of 0, which is undefined. Okay, and there we go. This is how we prove the sum of sequences or series formula of a geometric sequence. And that is our answer. Moving on to the next question. Question 3.2 says, given the geometric series, and we have a times x minus 2 plus 4 times x minus 2 all squared plus 2 times x minus 2 all cubed, and this keeps going, and they ask, determine the values of x for which the series will converge. Okay, when does a series converge? A series converges when r is greater than -1 but less than 1. Okay, so this is the kind of series that it just gets infinitely smaller, but it doesn't end. So it's an infinite geometric series that just gets smaller and smaller and smaller. You can kind of think about it like this. If this was a loaf of bread and I cut it in half, then I have a half piece. So I used to have one, now I have a half. And then if I cut that half in half, I have a quarter. If I cut that quarter in half, I have an eighth. If I cut that eighth in half, I have a 16th. If I cut that 16th in half, I have 1 over 32. Okay, And then you see how this will keep getting smaller and smaller and smaller, but it's never actually going to become zero because of the way numbers can infinitely grow, technically, because that's what the denominators are doing. Okay, so that's what a converging series looks like. And that's why we say it's infinite. It continues forever, but we are still able to find its sum. Okay, so because the series doesn't end, yes, but it's heading towards zero, we can still find the sum of that series. Okay, and that's where the sum to infinity comes in. So a series will always do this, always behave like this, if the ratio is greater than -1 but less than 1. Okay, but also just take note that ratio should not be equal to 0, because if it's equal to 0, that series is not going to converge. Okay, it's not, can't even consider it a geometric series in that case. So we'll keep this in mind. And now let's find out for which values of x it will converge. So let's find the ratio, because we need to work with that inequality with r. So find the ratio, and to find the ratio, you always say next term divided by previous term. This is a geometric series. So the next term is 4x minus 2 all squared divided by the previous term of 8 and then x minus 2. And what happens here? Well, this x minus 2, one of it would cancel here. So you're left with 1. And this one cancels here. Okay. And so you're left with x minus 2 in the numerator. But 4 divided by 8 is a half. So what we have is a half times x minus 2. We can go ahead and just distribute that in at this point. So this is a half x, and then that multiplies to become -1. Okay, so we need to just ensure that this ratio of 1 over 2x minus 1 is greater than -1, but less than 1. Okay, now also just ensure that r is not equal to 0. So if r should not be equal to 0, we're saying this ratio, a half x minus 1, should not be equal to 0. Okay, and so if you transpose the 1, we're saying a half x should not be equal to 1. And then if you divide both hand sides by half or multiply both hand sides by 2, okay, to make this x, then x should simply just not be equal to 2. Okay, so you see that's what we have there. Let's go ahead and solve for our inequality. So with this inequality, this is actually two inequalities that has been put as 1. So we're going to transpose the -1 and it becomes positive. So it's -1 plus 1, which is 0. Okay, and then we still have a half x here, and you're going to transpose it over to this side as well, because remember, there are two inequalities that are actually just been put as 1. So when you transpose that, that becomes plus 1. So 1 plus 1 is 2. And so this is what we have. And now to solve for x, we just need to get rid of a half. So divide or multiply all sides by 2. So I'm just going to multiply by 2. I'll say times 2 and times 2 and times 2. And now we have here, we still have 0. Here we'll have the x, and here we'll have 4. So for this series to converge, x just has to be greater than 0, but less than 4. But x should not be equal to 2. And that is our answer. Moving on to the next question. 3.2.2 says, if x is equal to 3.5, determine the sum to infinity of the series. Okay, so 3.5. You can also call 3.57 over 2, but it's fine. So how do we find the sum to infinity? Well, the sum to infinity is equal to a over 1 minus r. Okay, remember you have these formulas in your formula sheet. So we need the value of a and we need the value of r. Let's think about what those are going to be. If x is equal to 3.5, what is a? A stands for the first term of your series. Okay, so that is 8 times x minus 2. So if this is a, 8 times x minus 2, and we know now that x is 3.5, this is just 3.5 minus 2, and so a is equal to, that's 1.5, which is 3 over 2. What is 8 times 3 over 2? These cancel, that becomes a 4, that becomes a 1. So that's 3 times 4, which is 12. So a is equal to 12, great. Okay, and now we just have to find an expression for r, which we already found. So this is 1 over 2x minus 1. So we're going to say r equals 1 over 2, and then x is 3.5, then minus 1. Okay, 3.5 is 7 over 2. So this is a half times 7 over 2, which just gives us 7 over 4 minus 1. And you can express 1 as 4 over 4. So this is 7 minus 4, which is 3, and so 3 over 4. Okay, so our answer, r is simply equal to 3 over 4. Great, and now we can find the sum to infinity. Okay, so the sum to infinity is equal to, and we have a, which is 12, over 1 minus 3 over 4. Okay, let's just quickly calculate this. So this is 12 divided by 1 can be 4 over 4. So that's minus 3 over 4, which is 1 over 4. And so 12 divided by 1 over 4, you can just type in times. So 12 and then just say times 4 over 1. Okay, and so that is 48. So the sum to infinity of this series is simply 48. The sum of all the terms in the series is 48. And that is our answer. And that is it for question 3. Question 4 says, in the diagram below, the graphs of f of x, which we can see is a decreasing exponential function, and g of x, which is a hyperbola that we have over there, are sketched. The two graphs intersect at points A and B as shown on the sketch. The point A is a point where both graphs cross the y-axis, meaning this is a y-intercept. Okay, the asymptotes of the graph G meet at -1 and 3. Okay, and the question says, determine the coordinates of A. So we can see that A is the y-intercept of both graphs, and we may not have the equation of G, but we do have the equation of F. So we can find the y-intercept of this equation. To find the y-intercept, you simply just make x equal to 0. And so we're going to take the graph of F, so f of x, and we're going to say f of 0 in place of x, we substitute 0, and we'll say 1 over 5 raised to the power of 0. Anything to the power of 0 is 1. So this is 1. And therefore that point A is simply x value is 0 and the y value is 1. And that is our answer. Moving on to the next question. Question 4.2 says, determine the equation of G by finding the values of A, P, and Q. Okay, so with the equation of G, do you see that? Look at the graph. We have this point where their asymptotes meet. Now you need to remember what the original hyperbolic equation looks like. That is y equals a over x minus p plus q. But notice that they want us to find the value of p and q as well. So the p that they are referring to is their p. We know that the original equation has a negative p, but they have put a positive p there, so you need to remember what to do in that case. Think about what the original p is. The original p stands for that vertical asymptotes x value, okay? And since this is the point that these two asymptotes meet, it would mean that the x value belonging to this is -1, and the y value belonging to this is 3, meaning the vertical asymptote is simply x equals -1, the horizontal asymptote is y equals 3. And so this means that in our original equation of the hyperbola, this is p, x equals p. That is p here. So we would need to substitute it in here. And we can see that q is 3. So when we substitute that, that is y equals a over x minus, now our p is -1. Okay, so we'll say minus -1 and then plus 3. And so you see that if you simplify this, this is a over x plus 1 plus 3. And now it looks like their equation. Theirs is in the form of a over x plus p, because the p that they're referring to is this, which is a positive 1. So we'll tell them that p is equal to +1. So p equals +1. And we can also see that q is equal to, as we can see there, it is 3. That doesn't change. That just stays the same. So you'll notice that they will always put that little bit of a twist there. Okay, so just watch out for that. And then now, how do we find the value of a? Well, if we have p and q, it means that our equation is almost complete. Okay, these two values are already there. So only a is missing, meaning if you find a point with an x and a y value and you fill it in there, it will help you to solve for a. And that's what we're going to do. Do we have any point on this hyperbola? Okay, all through here, there's b, but we don't know what b is. And all through here, there's a, and we know what that is. That is 0 and 1. So just remember this is 1. And so we're going to substitute that point in. Okay, so our equation so long of our graph of g is simply a over x plus 1 plus 3. And we're going to substitute this point a into the equation 0 and 1. Okay, so we have 1 is equal to, as the y value, a over 0 plus 1 plus 3. Okay, 0 plus 1 is 1, a over 1 is a, so this is just a, and we can transpose the 3, so that's 1 minus 3. And so we know that a is equal to -2. So we can see the values of p, q, and a, and we can finally just tell them this means that g of x equation is -2 over x plus 1 plus 3. And that is our answer. Moving on to the next question. Question 4.3 says, determine the inverse of f and write it in the form of y is equal to. Okay, so what is f of x again? That was that. Okay, 1 over 5 to the power of x. 1 over 5 to the power of x. Now you can just rewrite this f of x as y and just make it easier. Now to find the inverse, we first swap the x and y value. So x is equal to 1 over 5 raised to the power of y. Okay, and then make y the subject. To make an exponent the subject, we use log. So we'll say log, and our base is 1 over 5, and that answer was x. Okay, so log of x to the base of 1 over 5, and that is our answer. Moving on to the next question. Question 4.4 says, sketch the graph of the inverse of f and clearly show any 2 points on the graph. So any 2 points. Okay, so the first point we can just show is one that is already on f, which is a. Okay, so we can show a. If a is 0 and 1, so what's going to be this point on the inverse? Remember that with the inverse, the x and y values switch places, right? So if on f we had this point 0 and 1, on the inverse, this point is going to simply be 1 and 0. Okay, so there's one point where we have. Now another point. We need another point on this. Okay, so I would have said b, but this is the intersection between an exponential and a hyperbola. Okay, this is for 3 marks. There's no way they want you to, find that. So I'm going to take another point. Let's see another point that we can take. There's no other point on this graph though. So the main thing about this is to just better get a good shape. Okay, to get a good shape of this graph, you take one point. If you take a point here, try to take a point more on the left. Okay, because it's just going to help you with the shape of that graph. So one will be higher than the other. So it is far away enough just so that, it actually does help that shape. So, okay, let's find that other point. I'll go for using this x value of -1, okay? Because I'm just trying to relate it to what we have there. Now, obviously, it's not going to be -1 and 3, no, because this -1 and 3 just stand for this intersection point of our asymptotes, okay? So -1 on the graph of f is going to be paired with a value over here, okay, not this 3. So let's just substitute -1 in the equation of f so we can find out its y value. Okay, so if we did that, we said f of -1, and we know that f is 1 over 5 raised to the power of x. So this is going to be 1 over 5 raised to the power of -1. Okay, the exponent is negative. If you applied it, you have 1 to the power of -1, 5 to the power of -1. To make the exponent positive, move the 5 to the numerator, move the 1 to the denominator. So you have 5 to the power of +1 over 1 to the power of +1, which is just 5. Okay, so we'll have this as 5. So f of -1 is equal to 5, meaning the inverse's graph. Okay, so we have this point, and the inverse's graph is going to not be -1 and 5. It's going to be 5 and -1. Okay, so we'll just say we have this point 5 and -1. So these are the 2 points that we're going to have on this graph. Okay, let us plan our graph out first. So just looking at the shape of it. Okay, if this is the exponential function, its inverse is going to be a logarithmic graph. So the log graph that we will have is going to look like this. Just look at what this graph is doing. So it is decreasing when we look at it moving from the negative part of the x-axis to the positive part. You see how it is moving down. So it starts from a high y value and starts to get lower as we go on. So this is going to do the exact same thing, but using the y-axis. Okay, so here we looked at towards the negative part of the x-axis, and we saw that the y value was this high. So towards the negative part of the y-axis, your graph is going to be this high, okay, over there. And then as you see, we are moving down like that, okay, as we move towards the positive part of the x-axis. So you're also going to move down like that as you move towards the positive part of the y-axis. Okay, it just does whatever it was doing on the x-axis. Now it will do that on the y-axis. And that's what the graph is going to look like. Okay, so let's just plot down our 2 points and then draw that graph. So here's our Cartesian plane. And our 2 points are 1 and 0. So an x-intercept of 1 and 0. So we can just say that's over here. Okay, if that's 1 and 0, then the other point we have is 5 and -1. So that's 5 on the x-axis and then -1. So somewhere about here. That's 5 and -1. And then let me actually just write it here. 5 and -1. So then when you draw your graph, remember the shape that it takes. Okay, it just moves down like that. So we're going to do the same thing here. We're going to join this graph like that. So we'll take it like this. And then from here, move down, connect, and move closer and closer to the y-axis, but never reach it. Okay, and there we go. So this is the graph of the inverse of f. And we have this point. I'll call this a prime since it's not that same point. It's now 1 and 0. And then we have this point over here. And that is our graph. And moving on to the next question. Question 4.5 says, determine the values of x for which the inverse of f is greater than or equal to -2. Okay, so to find out where it's greater than or equal to -2, first find out where it's equal to -2. So we'll find out where inverse of f is equal to -2. So we can do that by using its equation, which we now know is log of x to the base of 5. Okay, and so then we're just going to put it in exponential format so that we can solve for x and find out which x value has a y value of -2. Okay, so in exponential form, this is the base. Okay, it's still the base. So we're going to rewrite the base, raise it to the exponent. But remember with log, it makes that exponent the subject. So that is the exponent. And that would be equal to x. So x is simply equal to, if you apply this in, you'll see that you get 25. Okay, you can use a calculator, but because we know that those numerator and denominator will switch places because of their negative exponent. So it means that where x is equal to 25, we have a y value of -2. So we use the inverse graph, okay, because it's about the inverse. And we're going to look for where y equals -2. This is our y-axis. Here's where y is equal to -1. And so -2 will be somewhere here, okay? Yeah, now the way I drew the graph, it should actually still extend. So I'm just going to extend it like this, okay? Let's say I just did that and we're just increasing. Okay, but it is slanted. So while it's doing that, we're going to find a point on the graph with an x value of 25. And so they want to find out the values of x for which the inverse is greater than or equal to -2. So it means that if this is -2, all the values greater than -2 will be all up here. So you need to take all the values on this graph that have greater y values than -2, which would start from here, so equal to -2, and then everything above here is greater than -2. So now map this to the x-axis to understand which values they're referring to here. If we line this up to the x-axis, you see that these are all values that are, if this is 25, these are values that are to the left of 25. But then is it all just values that are less than 25 and then we just keep going? No, okay, because here on the y-axis, it's not going to go beyond the y-axis. And the reason why is because the original function, okay, the way it looks, you see how it looks like that, how it's not exceeding the x-axis. It means that there's an asymptote. And we can see that from the way they wrote this. The exponential function is written in the form of, so y equals a times b raised to the power of x minus p plus q, where q is your horizontal asymptote. Do you see that you have no plus q there? Okay, there's nothing adding to this. So it means that q is equal to 0. And so here, we have a horizontal asymptote of x is equal to 0. That means on the inverse, your log graph, you will have a vertical asymptote of y is equal to 0. So this graph will never pass this y-axis, meaning that these values, okay, that are greater than or equal to -2 are values that are, see, if you line it down, Okay, it's never going to go beyond 0. So it's values that are greater than 0, but less than 25. And that will be our answer. So we'll just simply tell them this is where x is greater than 0, but now I have to say less than or equal to 25. And the reason why is because they want values that are greater than or equal to -2. At -2, we have an x value of 25, so it's also equal to 25. And this is our answer. Moving on to the next question. Question 4.6 says, graph H is produced by shifting graph G 1 unit to the right, shifting it 1 unit to the right, and 2 units vertically downwards, rather than the equation of graph H. So here's the thing we need to know about left and right movements and vertical movements up and down. Okay, if you move a point or a graph, right, to the right, for example, or the left, if this point was 1 and 2, and it moves 2 units to the right, what is the new point going to be? So it's moving in a way that only the x value is going to change. This used to be 1. It's going to move 2 units to the right, meaning 2, 3. So now it's going to be 3 and 2. The y value didn't change. Okay, if you move a graph to the left or the right, it changes the x value. And if you move a graph up or down, okay, if we move this graph down by 1 unit, it will become 1 and 1. Okay, you see how only the y value changed. So moving a graph left and right affects the x. Moving it up or down affects the y. And here's now how we can simplify this or solve for this. We're taking this new graph of h of x, and we're saying it is a result of taking the graph of g and moving it 1 unit to the right. When you apply a right movement to the equation, if you are moving to the right, you're going to subtract. Okay, so you're going to say x minus that amount of units it moved. And if you're moving to the left, you're going to add. So this is moving 1 unit to the right, meaning we're going to take that x value and say -1. And then it moves 2 units vertically downwards. So the entire graph, okay, as a result of substituting that x minus 1, that's going to give you your y values. You're going to take that and you're going to move down by 2 units. Now, with the up and downward movement, there's no confusion with this. Down is minus and up is plus. So we're going to just take this and say -2. And this is what we're going to apply to the graph of g. So h of x is equal to, we know that the graph of g is our hyperbola. Okay, the a value was -2 and we have x plus 1. Okay, so that's -2 over x plus 1 and then plus 3. So our graph is now going to become, we have -2 over, now wherever you see x, subtract the 1 from it. So you have x plus 1, but you're going to say -1. You could even just say x minus 1 and then leave that plus 1 there. Okay, and then we had a plus 3 at the end, and now we're going to subtract the 2 from this. Okay, and so our equation of h of x is simply equal to -2 over x, and then 3 minus 2 is plus 1. And that is the equation of h, and that is it for this question. Question 5 says, the functions f of x is equal to a times x minus p all squared plus q. You can see that that is a parabola, and it is in the correct order of a parabola. Okay, they have not added a plus here or anything. And g of x is equal to -1 over 5x plus c. Okay, is this graph over here, are drawn below, with f passing through a, b, c, d, and e. A and B are the x-intercepts of f. D, 3 and 16, is the turning point of f. And then we have C, 5 and 12, is the point of intersection of graphs f and g. And the first question, 5.1, says, determine the value of C in the graph of g. Okay, so C, that y-intercept, is just that missing C value, meaning all we need to do is substitute a value for y and x, so we need a point, and once we do that, it will help us to find C. Okay, so do we have a point on this graph of g? Yes, we do. We have C over there, 5 and 12. So we can just go ahead and say that g of x is equal to -1 over 5 x, and we have plus C. And we're going to substitute that point C, which is 5 and 12. So in place of y and x. So 12 is equal to negative 1 over 5, and then 5 plus c. Okay, negative 1 over 5 times 5 is negative 1, so that is 12, and then negative 1 comes over to become a positive 1. Therefore, c is equal to 13. Okay, and that is C. Moving on to the next question. Question 5.2 says, determine the equation of f by finding the values of a, p, and q. Okay, so let's go ahead and look at our graph of f. What do we have? Well, first, it has been written in turning point form, which is great because they also gave us the turning point. This is the turning point at D, and so we know the values of p and q. The p value is the x value of a turning point, and q is the y value. Okay, so we can substitute those. So long we have f of x is equal to a multiplied by x minus p, but we know that is 3 now, all squared, plus q, and we know that is 16. So you see from this equation, the only thing missing is a. So if we can find one point to put in place of a y and the x, okay, those coordinates, then we can find the value of a. So we just need 1 point on the graph of f. So look at the graph of f. Do we have a point? Yes, we do. We have 5 and 12. So you see this is going in the same flow as the previous question, question 4. So we're going to substitute that point of c, which is 5 and 12. And we'll just say 12 is equal to a times 5 minus 3 all squared plus 16. And all we have to do is make a the subject. So to make a the subject, transpose 16. So you have 12 minus 16, which is negative 4, is equal to a. And then multiply by, this is 5 minus 3, which is 2. 2 squared is 4. And if you divide both hand sides by 4 to get a alone, you see that now we have that a is simply equal to negative 1. And so we have the value of a and we have the value of p and q, which I should have stated before substituting them. So p is equal to 3 and q is equal to 16. And so those are all our values, p, q, and a. And so the equation of f is therefore f of x is equal to negative 1 or negative x minus 3 all squared plus 16. And that is our answer. Moving on to the next question. Question 5.3 says, determine the equation of k of x, a line perpendicular, okay, perpendicular to the graph of G and passing through point E. Okay, so it's perpendicular to the straight line G and it passes through E. So it looks something like this. Okay, we're going to have our graph over there. Okay, so something like that, and it is perpendicular to G. So to find the equation of this graph K, it's still a straight line. So we can find it in the form of y equals mx plus c, meaning we need to find m, the gradient, and c, the y-intercept. So to find the gradient, we would use the gradient of the graph of G, seeing that they are perpendicular, and use the properties of perpendicular lines. So what is the gradient of G? As you can see, negative 1 over 5x plus c, that is the gradient, negative 1 over 5. So we'll simply say that to find the gradient of k, the gradient of G was negative 1 over 5. And so the gradient of k would simply be, just switch the numerator and denominator, which will give you negative 5, and then multiply this gradient by negative 1. So the gradient is 5, okay? And now that we know the gradient, they tell us that it passes E, right? So how do we find it if it passes E? Well, we need to know what E is so we can substitute that. And E is also a y-intercept. So this is actually much better. So how do we find E? It lies on the graph of f and it's the y-intercept. So take your equation of f and you're finding the y-intercept, meaning at the y-intercept, this is where x is equal to 0. So in place of x, substitute 0. So f of 0 is equal to, and that gives us negative 3. Negative 3 squared is 9, but we have a negative outside. So this is negative 9 plus 16. 16 minus 9 is, that's like saying 10 minus 3. So that is 7. Okay, so we know the y-intercept now. So it means that k of x is equal to mx plus c. Okay, the gradient is 5. And so 5x, and the y-intercept itself, this is the y-intercept. Okay, so plus 7, that is c. And that is the equation of k of x. Moving on to the next question. Question 5.4 says, determine the values of x for which f of x is greater than or equal to k of x. Okay, let's look at our graphs where f of x is greater than or equal to k of x. Okay, it's a parabola and it's a straight line, but I don't think it would be a wise decision to use the graph here in this case, because at the end of the day, you still need to find out where it is equal to, okay, k of x as well. So let's solve this using algebra really. Okay, so we're going to just say, where is f of x greater than or equal to k of x? And we know that the equation of f of x is this. So we're going to take this equation and substitute here. And we'll say, where is it greater than or equal to? And we know that this is 5x plus 7. So 5x plus 7. And let's solve for this inequality. Okay, distribute. So we have negative, and this now becomes x squared. And we say first term times second term, which gives us negative 3x, then times 2. Instead of writing it twice and then foiling out, okay, that takes long. So this is negative 6x, and then plus 9. Okay, we square the last term. Then we have plus 16, and this is greater than or equal to 5x plus 7. Okay, and now we can distribute this in. So this is negative x squared plus 6x minus 9, and then plus 16, and we can transpose. So minus 5x minus 7 is greater than or equal to 0. And we have negative x squared, and if you say 6x minus 5x, you get positive x. And negative 9 plus 16, or just say 16 minus 7, and that gives us 9. So that's negative 9 plus 9, which is 0. So those cancel, and we have greater than or equal to 0. And now we can take out a common factor. It's best to take out a common factor of negative x, okay? And then what we have left, if we divide here, we have x left. If you divide here, you have negative 1 is greater than or equal to 0. Now, to solve for this inequality, we have one thing times another thing is greater than or equal to 0. You can draw your parabola. So when we simplified and the one-hand side was equal to 0, do you see that this is a parabola, right? It's a quadratic expression, but the value of the coefficient of x squared is negative. So it will form a concave down parabola. And this is specifically a concave down parabola where you can see the y-intercept is 0. Okay, so on the y-axis, we have that y and x-intercept being 0, meaning this is 0. The first x-intercept is 0. And the other x-intercept, okay, if you just say negative x equals 0, you can actually just put down your critical values. You can show them. If you had to solve for x in this equation, right, you would say negative x equals 0, therefore x equals 0, or x minus 1 equals 0, therefore x is equal to 1. Okay, so we can see that our critical values are 0, and we have x is equal to 1. And this inequality specifically says that this expression, the y values, okay, the result of substituting x values, we need to find out the x values for which this is going to be greater than or equal to 0. So where does this graph have positive y values? Okay, all of this, when we substitute it, gives us a y value. It will have positive y values everywhere that is above the x-axis. Okay, if you go below the x-axis, you see that if you map these to the y-axis, these will give you negative y values. Okay, they're below 0. So it's all through here. And if you map these down to the x-axis, you see where these values are. These are values that are, remember, they need to be greater than or equal to 0. So these are values that are greater than or equal to 0, but less than 1. So our answer here is simply x is greater than or equal to 0, but less than or equal to 1. And that is our answer. And moving on to the next question. Question 5.5 says, it is further given that the graph of h of x is equal to 2 raised to the power of negative f of x. Determine the minimum value of the graph of h. Now, in this question, you need to be careful not to see minimum value and then jump to the conclusion that, oh, we just need to find the minimum value of f. No, okay? You need to look at the nature of the expression you have. This is an exponential expression because the values we're going to substitute will be in the exponent. Okay, now look at this. We're going to look at 2 to the power of negative f of x. And to explain this, I'm going to substitute 3 values. And you can always do this to brainstorm it and to just think it through. Okay, so let's try 2 raised to the power of negative, and then we're going to put a value over there. and then repeat it. So let's just put one value in the middle, one middle value, and then one value smaller than that, okay, an exponent smaller than this one, and then an exponent bigger. Okay, so we can see the direction that this is going to ensure that this entire expression is the smallest possible value that it can be. That would be the minimum value of h. Okay, so with this, let's try 2, right? If we raise this to the power of 2, then let's try a smaller value here. Let's try 1. And here, let's try a bigger value, 3. Okay, so 1, 2, and 3. And we're just trying to see which direction we should go. Should we make this number bigger or smaller? Okay, so if we find the values of this, 2 to the power of negative 1 is a half, right? And a half as a decimal is 0.5. And then 2 to the power of negative 2 is a quarter. And that expressed as a decimal is 0.25. And then 2 to the power of negative 3 is an eighth. And that is 0.125. Between these three numbers, which is the smallest? It would be 0.125. Okay, that's a smaller number. You can easily see this by looking at the decimals. Okay, 0.5, 0.2, 0.1. This is the smaller number. Okay, so that first decimal. So it would mean that if you make this number any bigger, you will get an even smaller value. Okay, so it means that we need to ensure that this value of f of x is at the highest possible y value it can be. In other words, f of x needs to be at a maximum. So if we can find that maximum value of f of x, that will ensure that this is going to be the smallest value it can possibly be, this expression of h of x, 2 to the power of negative f of x. Okay, so we need to find that maximum. Okay, so let's find out where f of x is a maximum. The graph of f of x, as you can see, is a concave down parabola. So we actually do have a maximum here. The maximum value of this graph, you see it has all these y values. We're referring to the y values. This is a negative y value, another negative one. This is a positive one. But the highest that it reaches is this y value of 16. So that is the maximum. And it happens at x equals 3. Okay, so we can see that it is a maximum at 3 and 16. The highest y value we have is 16. So substitute that in here, and that would be the smallest possible value 2 to the power of negative f of x would be. So h of x, right, would be a minimum where this is a maximum, and we're just going to substitute. This will be 2 to the power of negative 16. And let's just find that on our calculator. So 2 to the power of negative 16. Okay, so we can actually see that. That is simply just 1 over 65,536. That would be the minimum value of the graph of h, and we can just conclude that. Okay, and there we go. That is the minimum value of the graph of h. And that is it for question 5.5. Moving on to the next question. Question 5.6 says, determine the average gradient of graph f between x is equal to negative 3 and x is equal to 1. Okay, so it's of graph f between 2 points. So to find the gradient, the average gradient, okay, can be found by simply just saying y2 minus y1 over x2 minus x1. So y2 will be found as a result of substituting this x2, okay? This is the second x value, this is the first x value. So we'll simply just say, we'll find this by saying f of 1 minus f of negative 3, okay? y2 minus y1 over x2 minus x1. And we know the x values, so that is 1 minus negative 3, okay? So let's just substitute. I'm just going to put it in as it is. So let's take that equation of f and then substitute in there. Okay, so this is that graph, and we're just going to substitute those x values in. This is going to be 1, and we're going to say minus. Now you see that we have two terms here. Okay, so you're going to have to protect this with brackets to ensure that it actually subtracts properly. So you're going to put brackets here, and then bigger brackets really. And then this is negative 3. Okay, so there you've substituted x in here of 1 and the x value of negative 3. And then we're just saying over, now the denominator can just simplify to 1 plus 3. And you just have to find this value. That's all. Okay, so at this point, let's just find the y values. Okay, so we know that we subtracted those y values. So this would simply be negative 2 squared, which is 4. And that's negative 4 plus 16. What is 16 minus 4? Is 12. Then minus, and then this becomes, that is negative 6 squared, which is 36. And this is negative 36 plus 16, which is negative 20. So minus negative 20 over 1 plus 3, which is 4. Okay, we can just find the answer. It's fine. So this is going to be 12 plus 20 is 32 divided by 4 is finally equal to 8. And that is our answer. And that is it for question 5. Question 6.1 says, given cos 17 degrees is equal to k over 5, without using a calculator, determine in terms of k each of the following. And we need to find sine 17 degrees. Okay, so this is going to be a trig diagram. And we know that 17 degrees lies in the first quadrant. Okay, it is greater than 0 degrees, but less than 90 degrees. So we have a diagram, and this is 17 degrees. And we're going to draw a line down to the x-axis perpendicular to that x-axis. Now, with this, they told us that cos 17 degrees is equal to k over 5. Now from SOHCAHTOA, we know that cos is adjacent over hypotenuse. So the hypotenuse is 5, while the adjacent side is k. And so we need to find that opposite side. Okay, so because it represents a y value, we can just call it y. And we'll say that y squared is equal to the hypotenuse squared minus the other shorter side squared. And so to solve for y, we would square root both hand sides. There's a positive and negative solution, but you can see that y is positive in the first quadrant. So y is equal to the square root of, and this is going to be 25, and that stays k squared. And that is what y is, okay? The square root of 25 minus k squared. So now what would sine 17 degrees be? Sine from SOHCAHTOA is opposite over hypotenuse. So it's the opposite side, which is the square root of 25 minus k squared over the hypotenuse, which is 5. And that is our answer. Moving on to the next question. Question 6.1.2 says we need to find the value of tan 253 degrees. Okay, so this angle can be reduced. So we can go ahead and say this is tan. So we can see that it's an angle that is greater than 180 degrees, but less than 270 degrees. So we'll use tan's reduction on this, which is 180 degrees plus theta. And so this is 180 degrees plus what gives us 253 degrees. Or 253 minus 180, let's just quickly find that. 253 minus 180 is 73 degrees. Okay, 73 degrees. And because this is in tan's quadrant, it's not going to become negative. So this will become positive tan 73 degrees. Okay, now we have 73 degrees. Remember, this diagram is a diagram with that reference angle of 17 degrees. So everything needs to relate to 17 degrees. How does 73 relate to 17? Well, if you add them together, if you say 73 plus 17, do you see that you're going to get 90 degrees? Now, remember, this is for 3 marks. Okay, you could go the long route, and the long route would be to convert this into sine and cos, and then, use cofunctions and that. But that would take a while. So here's what we can actually do. You see, in this diagram, we have found one angle. We know this is 90 degrees. You could simply just find this angle. Because you know that those were complementary angles, they add up to 90 degrees. It means that the other angle that we'll have here would be 73 degrees. Okay, if you add 17 and 73, they give you 90 degrees. So there. And now we're going to use this in reference to 73 degrees. What is tan 73 degrees? That is because it's tan in SOHCAHTOA, that's TOA, meaning the opposite over the adjacent. But it's the angle opposite 73 degrees. Opposite 73 degrees is K. And the adjacent, in this case, the side next to 73, is the square root 25 minus k squared. Okay, so that's what we're going to say. K over, this is finally equal to K over the square root of 25 minus k squared. And that is our answer. Moving on to the next question. Question 6.1.3. For 4 marks, we have to determine the value of sine 124 degrees. Okay, 124 degrees, how does this relate to 17 degrees or 73 degrees? How does this relate? Okay, let's try 17 degrees just because 7 plus 7 is 14, so that 4. And let's see how we can get this. So 17 plus 17 is 34. And if you say 124 minus 34, just trying to understand that, we'll get 90 degrees. Okay, so clearly what they did was this. They said we're going to separate this as sine 90 degrees plus 34 degrees. And then straight away you see that we're using cofunctions. So this is sine 90 plus theta. It's like sine 90 plus theta. And we know that this is equal to cos theta. Okay, it's not the one that becomes negative. The one that becomes negative is cos 90 plus theta. So this is just going to become cos 34 degrees. Okay, so we can use double angles to expand this. This is cos 2 times 17 degrees. And now we're going to have to think about the expansion that would be simpler to use. So yes, we have, I think we found cos, right? We found the value of sine actually. Okay, let's see if cos is simpler than this. So cos 17 degrees, that will be adjacent over hypotenuse. That is simpler. That is k over 5, and we can just use that. So we'll use the expansion 2 cos squared 17 degrees minus 1. So this is equal to 2 multiplied by k over 5 all squared minus 1. And so this is 2, and then we have, that becomes, okay, in the numerator, we just have k squared, and the denominator is 25, and then minus 1. So do you see that these are two terms? Initially they were, okay? This is one term on its own, and that is another term, okay, separated by that minus. So we're going to simplify this together, and now we have 2k squared over 25 minus 1. Because the denominator is here and we are subtracting, when adding or subtracting fractions, the denominators need to be the same. So we can rewrite this negative 1 as negative 25 over 25. And so to write it as one single fraction, we have 2k squared minus 25 all over 25. And that is our answer. Okay, that is the value of sine 124 degrees. And moving on to the next question. Question 6.2 says, given sine alpha minus beta is equal to, okay, sine alpha cos beta minus cos alpha sine beta, use the above identity to deduce that cos alpha minus beta is equal to that expansion of cos alpha minus beta. So in this case, we are using this rule that we have here to expand this one. So we're really focused on this. We're just using this one's rule. So we're going to use cos alpha minus beta, but using this rule, we need to create an expansion for this. Well, the problem with this is, to use this rule, we need this to also say sine, okay, not cos. So we're going to have to change that, and we can do that using cofunctions. Okay, so this is looking at this as if we have cos A, for example. If you want to change it to sine, you can change it to sine by saying sine 90 degrees minus A. Okay, so we're going to do the same here. We're going to say this is sine, and we have 90 degrees minus, and this is our A. Okay, it's the alpha minus beta. Okay, so you see that here we have sine alpha minus beta. We have sine of an angle minus another angle. Okay, to ensure that we can have an angle in terms of alpha, we're going to have to distribute this in. We can't take 90 degrees as our first angle and then this as our second angle, because this is alpha and beta. Okay, so let's go ahead and expand. That is sine, and then this is just 90 degrees, and then distributes in minus alpha, and that becomes plus beta. Okay, so now that we have this, we are going to ensure that one angle is in terms of alpha. And to do that, we can group 90 degrees and alpha together, and then this is in terms of beta. But there's another problem here. You see that it's sine of an angle minus another angle. But now here we have plus. So that needs to change to minus. And the only way we can change it to minus is just rewrite this, but we're going to change that plus beta into negative. Okay, so this will become minus negative beta. And see, we have not changed the value of anything. We've just changed the way it looks, because negative times the negative will still give you a positive. And now it's in the correct order. It's in the order of sine of an angle minus another angle. Okay, angle minus another angle. And let's get expanding. So applying this rule, because they said sine alpha, okay, if you have sine of a first angle minus another angle, it's going to be equal to sine of that first angle. So we will also say sine of our first angle is 90 degrees minus alpha. And then we have cos of the second angle. So we'll say cos of our second angle, which is negative beta. So cos negative beta. And then using this rule again, you see that if we have a negative here, we leave it as negative. So it's still minus. And then we have cos alpha. Okay, so cos of whatever the first angle was. So we'll also say cos and our first angle was 90 degrees minus alpha. And then sine beta, so sine of the second angle, sine, and our second angle here is negative beta. Okay, let's expand and simplify. What is sine 90 degrees minus alpha? That is equal to cos alpha. And then what is cos negative beta? Well, the angle is negative, so we can add 360 degrees to it. So this would be cos 360 degrees minus beta. But as you can see, this is in cos's quadrant, so it stays positive cos beta. And then we have here minus, and what is cos 90 degrees minus alpha? That becomes sine alpha. And sine negative beta, so add 360 degrees to that. So this is sine 360 degrees minus beta. We know that this reduction is in cos's quadrant, where sine is negative. So this reduces to negative sine beta. But you need to remember that these two are being multiplied. Okay, so this is being multiplied. And so if you have a negative sine alpha times negative sine beta, they become positive. So this is cos alpha, cos beta, and it becomes plus sine alpha, sine beta. And there we go. We have created the identity. We have expanded this to that, and that is our answer. Moving on to the next question. Question 6.3.1 says, simplify the following expression. Okay, and we have cos 60 degrees plus x and sine 30 degrees minus x. Okay, there is the one way to simplify this. You're going to have a lot of terms, and you're going to have to make sure that you just keep track of your terms. But I'm going to actually deal with this like this, because I see a 60 degrees with cos and a 30 degrees with sine. I'm going to change this one, okay, using cofunctions. So if this is cos 60 degrees plus x, we could change it to sine 90 degrees minus 60 degrees plus x, okay, using the concept that we just used previously. And then this is still plus sine 30 degrees minus x. And then this is going to be equal to, we have sine. And when we distribute in, this is 90 degrees minus 60 degrees minus x. 90 minus 60 is 30. So this becomes sine 30 degrees minus x. And you see how it is identical to the second term. Okay, so we have 30 degrees minus x over there. And because they're exactly the same, if you had sine x plus sine x, it just gives you 2 sine x. Okay, this is the like term. So we're going to add those together, and then they give us 2 sine 30 degrees minus x. And now we can use the compound angle expansion for this to simplify that, expand it. Okay, so it's 2 multiplied by, and this is sine 30 degrees cos x minus, it stays minus like the above rule that we had. And then we have cos 30 degrees sine x. Okay, and now we can simplify. So this is 2 multiplied by, sine 30 degrees is a half, multiplied by cos x. Notice cos x is going to be in the numerator. It's cos x over 1 technically. And then we have minus cos 30 degrees. Okay, that's going to be root 3 over 2. And then multiplied by sine x, which is also in the numerator. So what happens here is you are multiplying by, we don't even have to bother about this, okay? It's just a half cos x and negative 3 over 2 sine x. And when they multiply with the 2, okay, 2 times a half is just 1. So this will stay cos x, and then 2 times negative root 3 over 2 is just going to be negative root 3, and then we have sine x. And that is our answer, okay? And that is this expression simplified. Moving on to the next question. Okay, and the next question says, hence or otherwise, determine without the use of a calculator, okay, the value of this if x is equal to 45 degrees. So you saw that this in the previous question simplified to cos x, okay, minus square root 3 sine x. But we know now that x is 45 degrees. So in place of x, we substitute 45 degrees. Okay, now 45 degrees, 45 plus 45 is 90. So sine 45 degrees and cos 45 degrees, okay, they would become the same thing since we have complementary angles there. So cos 45 degrees is equal to 1 over root 2, but this is if I'm not using a calculator. If I was using a calculator, it would be root 2 over 2. So yeah, without the use of a calculator, I would use it like this and say minus root 3 and then multiply by sine 45 degrees, which is 1 over root 2. Now, if you use the calculator for this part, for cos 45 degrees, you would get root 2 over 2. And then this would be minus the squares of 3. And then we have multiplied by sine 45 degrees, which is also root 2 over 2. Okay, so we can look at what both answers would be. One is just with a denominator that is an irrational number. One is with a rational denominator. Okay, so these are still two terms, so you need to simplify term by term. So this is 1 over square root 2 minus, and when you multiply here, you just get root 3 over root 2. And if you simplify this, it's simply the denominator is the same, so you can write it over a common denominator, and we have in the numerator 1 minus root 3, and that would be our answer. Okay, if you use the calculator, however, it's going to be the square root of 2 over 2 minus, and we have square root of, now these two are multiplying. They're both surds, okay? When you're multiplying a square root with a square root, they're just going to lie under the same radical. So it's just 3 multiplied by 2, which is the square root of 6, okay, over 2. And then again, if we write them together, it's just going to be over a common denominator of 2, so it's root 2 minus the square root of 6. Okay, so both answers would be valid. This would be completely without a calculator, and this is with a calculator when substituting cos 45 degrees and sine 45 degrees, and that is our answer. Okay, moving on to the next question. Question 6.4, we are told to prove that this left-hand side is equal to the right-hand side. Okay, so we can expand the left-hand side. So let's rewrite it first. Okay, and this is equal to, so we have 1 minus, now the cos 2 theta, we have to decide here. Okay, we remember that we need to make it tan theta, right? It needs to become tan theta. So if it simplifies to tan theta, it means that the numerator was sine theta and then the denominator was cos theta, seeing how this is a fraction. So this needs to simplify to sine theta, and that needs to simplify to cos theta. That may not be so possible, seeing that you have a double angle here, if we decide to leave this one. So the main goal is now get rid of this one so that you can have this expressed as one term, and then we could take out a common factor in the numerator and a common factor in the denominator, and then it will probably solve that problem. Okay, so 1 is a distraction here. We need to get it out. So we have cos 2 theta and sine 2 theta. But sine 2 theta doesn't really have a choice. It only changes to one thing. Okay, sine 2 theta will only change to 2 sine theta cos theta. So I'm actually going to put that down first. So just leave some space. So this is 2 sine theta cos theta. That's what the other term looks like. So what should we change this to get rid of this one? Okay, remember that there's a negative in front of it. Okay, so we know it's always going to change into something that has two terms. Okay, because it's cos 2 theta. This is still plus that. Because this one is positive, right? But there's a negative here. If you change it to the identity of cos theta that has a positive one, you see how that's going to become negative 1, and it will cancel with this positive one here. So that's my goal. I can go ahead and change this to 1 minus 2 sine squared theta. Okay, and then in the denominator, this one, well, not really necessary. This is just the plus. And because this is positive 1 and this is just plus, and nothing is going to multiply into change a sign, what we can do is simply change this to something that will have a minus 1 so it can cancel with this positive 1. So we can change that to 2 cos squared theta minus 1. Okay, and then this is still plus sine 2 theta, so it still changes to 2 sine theta cos theta. Okay, and there we go. Always just decide, or using a pencil, think it through. If not, you're going to end up doing a whole trial and error thing. So now if we distribute, this is 1 and this is minus 1, okay? And then that becomes positive 2 sine squared theta, okay, glad it's positive, plus 2 sine theta. And you can already see what the common factor is going to be here. And then in the denominator, you see how those two would cancel. I'll just rewrite it as it is first. Okay, so this is equal to, and these two cancel, and now we're left with 2 sine squared theta plus 2 sine theta cos theta all over, and in the denominator, you see how 1 and negative 1 would cancel. Okay, that's why I said you need to think about what it should become instead of changing it to random things, because then you're going to end up having this whole trial and error situation, and you don't have time for that during the exam. Okay, so now looking at that numerator, we have two terms. What is common? Okay, we have 2 sine theta common. Okay, and then what is left? In the first term, if you take 2 sine theta out, just divide. That gives you sine theta. In the second term, this divided by 2 sine theta just gives you positive cos theta. Okay, all over, and then we have, in these two terms in the denominator, you can see what is common is 2 cos theta. Okay, there's our sine theta over cos theta. And then what is left in the first term? Okay, if you divide, we get cos theta. And in the second term, if you divide, you just get plus sine theta. Okay, so the factor in the numerator and denominator are exactly the same. They will simplify to 1. Those divide and simplify to 1. And so we still have now sine theta over cos theta, which is equal to its identity of tan theta. And that is our right-hand side. And we have proven the identity. Okay, moving on to the next question. Question 6.5 says, determine the general solution of the equation cos 2x plus 5 sine x equals negative 2. Yeah, now with this, I almost celebrated because I saw sine and cos. Yeah, but the thing is, you have sine x and cos 2x. You can't form tan with that, okay? So we're going to have to think about what this will expand to. There's two choices. Maybe you wanted to expand to tan, but actually that's not possible because this is a double angle. So it's always going to become something with sine squared x or cos squared x. So you see, squared x and x, they're not the same thing. So we're not going to do that. Let's think about this. This is 5 sine x. If we change this to something with sine, it's going to include a sine squared x, and then it could be a trinomial. So let's go with that. So I'm going to go ahead and change this cos 2x to the identity 1 minus 2 sine squared x. And then we have plus 5 sine x is equal to negative 2. You can't just bring this 2 over, it's fine. But okay, let's just see. So if we say minus 2 is equal to 0, okay, I'll just leave it equal to negative 2 and I'll just take everything over there. So we'll have 0 is equal to positive 2 sine squared x. And then this will become a negative 5 sine x. And then this is minus 2. But then also remember that you still have this positive 1 here. So when it comes over, it becomes minus 1. Okay, so we just have the equation 2 sine squared x minus 5 sine x minus 3 is equal to 0. Okay, how do we factorize this? So I'll open up two brackets already, equate to 0. But you see, to get the first term, 2 sine squared x, you must have said 2 sine x multiplied by sine x. Okay, if this is too intimidating, you can just say, in place of sine x, I'm going to say k. So this will become 2 And this is sine squared x, so it will be k squared, and then minus 5, and then sine x, so it will be k, and then minus 3. And then factorize that, and then in place of k, replace it back with sine x. You could do that. But I'm just going to take it like this. Now, we need factors of 3 that ensures that the middle stays negative 5. Okay, and one of these need to be negative. So if I put it as 3 and 1, and I see how that's not going to work, I'll put it as 1 and 3. Because when we multiply across like this, we can get 6 sine x, and when we multiply here, we get sine x. So if I make this negative, if we multiply across, this is negative 6 sine x, and this becomes positive sine x. And this will simplify to negative 5 sine x. Okay, so there we go. It is the middle term. So we know that these factors would work. So our factors are 2 sine x plus 1 and sine x minus 3. Great. And now we can solve for x. So 2 sine x plus 1 equals 0, or sine x minus 3 equals 0. So if you transpose that one, it becomes negative, and then divide both hand sides by 2. Sine x is simply equal to negative 1 over 2. Or here, transpose that, negative 3, sine x is equal to positive 3. And we need to solve for x in this, find the general solution. Now, one of this does not make any sense, and it is this one. You see the sine graph, right? The sine graph, the way it looks like that, it reaches the highest of 1 and the lowest of negative 1. If we're saying that sine x is equal to 3 and we need to find the x value for which sine x is equal to 3, this does not happen. Of course, on the sine x graph, okay? Because 3 is way over here, and you see that this graph will never reach 3. There's no graph up here. So this one cannot even happen. We'll just say that sine x is never equal to 3. Okay, it's not applicable. We'll just leave it like that. And then we'll go on to this one, and we can actually solve for x here. Okay, so we just have to solve for this. Now, I'll just use the simple approach that most people use. Because it's sine, it's fine, I'll use this, okay? But with the tan graph, I don't like to use this method. But here, it's fine. So we can use the cos diagram method. Okay, so we're going to find its reference angle first. And you find the reference angle by finding arc sine of the absolute value of this. If it's negative 1 over 2, you don't say shift sine negative 1 over 2. You say shift sine positive 1 over 2. Okay, and that will give you the reference angle. So we can see that it's 30 degrees. Okay, now that we know that, we can use the cos diagram and ask ourselves, where is sine negative? Okay, sine is negative in the third and the fourth quadrant, in tan and cos's quadrant. The reductions there are 180 degrees plus theta and 360 degrees minus theta. So this is simply going to be to solve for this angle, okay, x. We'll say x is equal to, and the first solution will be found where we say 180 degrees plus our reference angle of 30 degrees, and then we'll say plus k 360 degrees, or where x is equal to, and then we'll say 360 degrees minus 30 degrees plus k 360 degrees. Okay, so here, x is simply equal to 210 degrees plus k 360 degrees, or x is equal to, and that's going to be 330 degrees plus k 360 degrees. Do not forget to tell them that k is an element of integers. You can only use integer values there. And that is our answer, okay? And that is the general solution to this equation. And that is it for question 6. Okay, so that is it for this paper. That's the last question. And that is it for this entire paper. I hope you guys enjoyed it. If you do have any questions, feel free to leave it in the comment section, and I will see you guys in the future videos.